Okay, so Unit 9 is solving right triangles, which involves trigonometry. Hopefully that's not bringing back nightmares for you. But the first thing about trigonometry is that you have to know the names of the three sides of a right triangle. Here's a right triangle. It just means that it has one 90-degree angle, and it's usually identified by a little square like that in the corner. So mathematicians, we don't like to use long words. Instead, we like to use letters that represent long words. So the first um, letter, H, is for hypotenuse. And this is how you find the hypotenuse. You go to the 90-degree angle and you go to the longest side that's opposite it, okay? So this will be identified as the hypotenuse. So again, I always ask students to go to the 90-degree angle and just, go opposite the 90-degree angle, and that'll be the hypotenuse. Now the next two sides, the opposite side and the adjacent side, are done relative to the angle in question. So here, this little x degrees, that's the angle in question. That's the angle in a problem that we'd be looking for. So again, if you just, take your pen or your finger and move opposite this angle, you will have the side that's opposite, and we put an O there. That leaves one side left, and that's called the adjacent side, and adjacent means beside. So if you look right here, this side is beside the angle. It's actually part of the angle. H is also part of the angle as well, but remember that it's across from the 90-degree angle, so that's the hypotenuse. So I find if you find the hypotenuse first, then find the opposite side, then the third remaining side is the adjacent side. So let's take a look at another triangle here. You can see that the angle in question has moved up to the top. So first thing we're going to do is look for the side that's opposite the 90-degree angle. It's always the longest side, labeled the hypotenuse. But this time, because this is the angle rather than this one over here, when we move our pencil opposite this angle, we end up with the opposite side being down here, and the third side that's remaining is the adjacent side, okay? So no matter where the angle in question is, the hypotenuse will remain the same, okay? But the A and the O will flip. If you remember up here, the A and the O were there, okay? Now I'm going to get to do a fun little chant, okay? So here we go. SOH CAH TOA. All right, so in right triangles, there are three ratios, okay? This one's pronounced the sine ratio, even though it's shortened to sin. And in a right triangle, if you take the length of the opposite side and you divide it by the length of the hypotenuse, that is known as the sine ratio. And so we have this little chant to help us remember this. In a right triangle, if you take the length of the adjacent side and you divide it by the length of the hypotenuse, you have what's called the cosine ratio, and it's usually we just write the first three letters of cosine. And finally, and this seems to be the ratio that's used most frequently, it's called the tangent ratio, and it's usually just expressed as tan. In a right angle triangle, the tangent ratio is equal to the length of the opposite side divided by the length of the adjacent side. So I'm going to show you three problems. One of them we're going to be looking for an unknown angle, and the other two we're going to be looking for an unknown side. So we'll start with the ones where we're looking for an unknown side. So this is how you solve a problem like this. You got to have a calculator, or at least a phone calculator. You got to make sure your calculator's in degrees. But this is what you do. Okay, so here's a triangle. It's a right angle triangle. and it has a 30-degree angle, and it has an opposite side. So let's go ahead and label this the opposite side because it's opposite the 30-degree angle. I'm just going to put an O right there. And since this side up here is the hypotenuse because it's opposite the 90-degree angle, I know that the unknown side is the adjacent side. It's beside the 30-degree angle. So again, SOHCAH, I look for the O and the A. It's not there. It's not there. Here it is. The tangent ratio is the length of the opposite side divided by the adjacent side. So I'm just going to start with this, and I'm going to start replacing each letter with the information that I know. So for example, here, I know that the angle in question is 30 degrees. So I'm just going to write the tan of 30 degrees right here, okay? Do I know the opposite side? I sure do. I know that it's 100, okay? And do I know the adjacent side? Not yet. And what you usually do is you replace the A with the X, which is the unknown. Okay, so at this point, you have to use your calculator to find what the tan of 30 is. Now, some calculators, you put 30 in and press tan. Other calculators, you press 10 and then you press 30. Find out which one you have. You're probably going to be using your phone calculator. And we usually go 4 digits deep. So I don't know if you can see this, probably not. Well, there we go. I just pressed the tan of 30 and I got decimal 5773. We round up to decimal 5774. It's really important for accuracy if it's possible, because sometimes your answer might be 0.5 and that's all you can do. But in this case, you want to go 4 digits deep whenever you can. Okay, so I now have this ratio. Okay, so this is whenever you have the let me just put a line here. Whenever you have the X or the unknown on the bottom, you can just switch this decimal with the X, and that'll give you the correct answer. So you can just go ahead and write X equals 100 divided by 0.5774. Okay? And I'm going to go ahead and put down in my calculator 100 divided by 5774, and I'm going to get a wrong answer because give me a second here. 100 divided by 0.5774 is equal to 173.19. Okay? And that's, that answer should make sense because when you have a tangent ratio of 0.5774, it's telling you that the opposite side, 100, is about 57.74% of the adjacent side. And we just discovered that the adjacent side was 173.19. And in fact, 100 is 57.74% of 173.19. But just remember that when the X is on the bottom, like this, the unknown, you can switch it with your decimal, switch places, and you'll get the answer. Okay, so we're going to take a look at another question here. And in this, hopefully, if I've done it right, this time the, let me just put the angle here. This time the unknown, the X will be on the top. Okay? Hopefully. Anyway, let's see what happens. So here, again, I label the hypotenuse. It's right across from the 90-degree angle. And I know that this is the opposite side over here because it's opposite the angle. So this must be the adjacent side. So this is the one that a lot of students call caw. They sound like a crow. I love crows. Anyway, let's go over here. We're looking for AH. It's not there. It's not there. There it is. It's the cosine ratio. So again, we're gonna have to work sideways here. I'm running out of room, but cosine is a over h. I'm going to write it's the cosine of 30. I know the a is the unknown, it's x, and I know that the h is going to be replaced by 100. So again, I'm going to use my calculator. You press 30, and then you press cosine, and you get decimal 8660. So this would be one where you could only put 3 digits, but and so we end up with decimal 866 equals x over 100. The great thing about this one, when the x is on top, is to find x, you just have to cross multiply. That's why I put this little line here. So x will be equal to decimal 866 times 100. So therefore, x is 86.6. And whatever, if this was centimeters, it would be centimeters. Meters, it would be meters. And that makes sense if you think about it, because we're told that when you have a 30-degree angle in a right angle triangle, the adjacent side will be 86.6% of the hypotenuse. And of course, 86.6 is 86.6% of 100. So I'm going to stop here for now. And in the next video, I will just show you how you can use trig functions, the inverse of them actually, to find a missing angle. Okay, hope to see you today at the team meeting at 1 o'clock. Bye-bye.